Today we're going to look at section 2.2, and our objective today is I can use properties from algebra and properties of congruence. Right. So the first properties are properties of equality. These are the ones that you used in algebra to solve equations. So the addition property. Okay, the addition property says that if x equals 7, then you can add the same amount to both sides, and the result is still equal. Then x plus 3 equals 7 plus 3. Or x plus 3 equals 10. So if you add the same amount to both sides, then the value is still equal. So if you have a equal b, then a plus c equals b plus c. Okay? Then we have the subtraction property. Okay? And it says if a equals b, then a minus c is going to equal b minus c. So an example of that would be if x equals 10, then x minus 3 equals 10 minus 3, or x minus 3 equals 7. The next property is the multiplication property. Okay, and it says if a equals b, then a times c equals b times c. In other words, if you multiply both sides of the equation by the same number, then the equation is still equal. So if x equals 2, then 2 times x equals 2 times 2. Or in other words, 2x equals 4. The division property, and remember all these properties are the properties that you use in algebra to solve algebraic equations. Okay? But now we have to know the name of them. So it says if a equals b, then a divided by c has to equal b divided by c. Okay? So an example of that is if 2x equals 4, then 2x divided by 2 has to equal 4 divided by 2, or x equals 2. And then we have the substitution property. Okay, we use this very, very often in geometry. Okay, so it says that if a equals b and a equals c, then c equals b. In other words, we can substitute an equivalent value. So if x equals 3 and x plus y equals 7, then we can rewrite that as 3 plus y equals 7. So notice that what we did there is we replaced the x with what it was equivalent to. Okay? So that is the substitution property. And the final property from algebra that you used quite often in solving equations was the distributive property. Okay? And remember, it just says that if you have A times B plus C, then that's equal to A times B plus A times C. In other words, you can distribute through. And remember, the distributive property goes back the other way. So if you have this, you can take out the common factor of A and rewrite it like that. Okay? So, some examples. So, number 1, if length of AB equals length of CD, and length of BC equals length of BC. Oops, it's supposed to be length. Then, length of AB plus length of BC has to equal length of CD plus length of BC. Let me write that so you can read that. So what property was used there? Okay, what happened? We started with this and it became this. So what happened to both sides? This was added to both sides, so this was the addition property. Number 2, if 2 times the measure of angle 1 equals 72, then measure of angle 1 equals 36. All right, so this was what we started with. What did we do to that to make it this? Well, we divided both sides by 2. So that was the division property. We applied the division property. Okay, number 3. Oops, it's a funny looking 3. Number 3, if measure of angle A equals 1/2 measure of angle X, and 1/2 measure of angle X equals measure of angle B, then measure of angle A equals measure of angle B. Okay, so we had this statement and this statement. And so we ended up with this by application of what property? That's right, substitution property. Okay? Right. Number 4. If point B is in the interior of angle XOY, then measure of angle XOB plus measure of angle BOY has to equal measure of angle XOY. Well, let's look at the picture. We have angle XOY, and B is in the interior, so we can draw this. Okay? And so what is happening here? We're taking this angle plus this angle, and we're saying it equals this whole angle. So that was an application of the angle addition postulate. So we can use postulates as reasons to do things also. All right, then that takes us to the properties of equality and congruence. Okay, and so we have the first one is the reflexive property. And here's what it says. It says A equals A. Or in geometry, we would say length of DE equals length of DE. So something is equal to itself. Or measure of angle 1 equals measure of angle 1. Okay? So that is equality. But we can also talk about congruence. So this is equality. We can also talk about congruence. So if they're congruent, they're the same size and the same shape. So we would say segment DE is congruent to segment DE because DE is a segment and they have the same length. So therefore we can say it's they're congruent. Or we could, for the angles, we could say angle 1 is congruent to angle 1. Okay? So because they're both angles and their measures are the same, we can say that they are congruent. Then we have property 2, which is called the symmetric property. Okay? And it says that if you have A equal B, then B has to equal A. Okay? So in geometry we'd write something like this. If length of DE equals length of AB, then length of AB has to equal length of DE. And if we were talking about angles, it might be something like this. If measure of angle 1 equals measure of angle 2, then measure of angle 2 has to equal measure of angle 1. So basically you're just flipping it over. So that's for equality. Okay. Now if we're talking about congruence, then we would say if segment DE is congruent to segment AB, then segment AB is congruent to segment DE. Okay? Or if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Okay? And then we have what's called the transitive property. Now the transitive property very often gets confused with substitution. And in many cases you can interchange the two, but not in every case. So you have to be careful. So it basically says, get back to my page here. It basically says if A equals B and B equals C, then A has to equal C. So transitive is, the key is these two have to match, and then they drop out and this one is handed over to this one. Okay? So the transitive property for equality might be this. An example might be this. for geometry. If measure of angle 1 equals measure of angle 2, and measure of angle 2 equals measure of angle 3, then measure of angle 1 equals measure of angle 3. So again, notice that these are the same. So then this can be handed off to that. Okay, you have to have that order. So that's for equality. We can also write it as something as congruent. So we could say if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. This is a very, very important property. And again, notice these are the same, and so this is handed off to this, and that's where this comes from. Okay, so those are properties of equality. All right, now we're going to do an example of our first proof. So something that you have to prove, there are several parts. You must have a given. So in this case, our given is length of MI equals length of LD. And you have to have something that you're supposed to prove. We want to prove that length of ML equals length of ID. There should be a picture that relates what we're talking about. So this is point M. This is point I, this is point L, and this is point D. Okay? And normally in our class, we are going to do what's called a two-column proof, where the first column are the statements, and the second column are the reasons that you can make that statement. Okay, then most of the time, I would say about 99% of the time, your first statement is going to be the given. So length of MI equals length of LD. And we can say that because it was given to us. Okay, now in our picture, we want to look at the picture and see what does that tell us. Length of MI equals length of LD. So that is telling us that this segment is congruent to this segment, or has the same length, I should say. So those two have the same length, okay? Then you think about, okay, what is it that I'm trying to show? I'm trying to show that this is equal to this. And notice that those two parts overlap right here. Okay? So this green, the length of LI, belongs to this one, and the length of LI belongs to this one. So I need to introduce IL to the statement column. So I can use the properties of algebra, or the properties that we just learned, and I can say, well, length of IL equals length of IL by the reflexive property. So the reason I can write that is reflexive. Okay? Now, if I take this and add it to that side, and I take this and add it to that side, because notice that ML, I should have done that in a different color. Notice that ML is made up of MI and IL. So if I add that to that side, I get that whole piece. And the same thing for ID. Notice that ID is made up of IL plus LD. So I'm going to add IL to this side and IL to this side. So what lets me add the same amount to both sides? The addition property lets me add the same amount of to both sides. Then remember that we can use postulates. So we have a postulate that says if we add this plus this, it equals the whole. So we have a postulate that says MI plus IL equals ML. Notice what I've accomplished there. I've introduced ML to the statement column, and I needed ML in there because I needed to prove that. It is also true that LD plus IL equals what segment? ID. Okay, and again, notice what I've accomplished there. I have ID written in the statement column, and I need to prove that ID is equal to ML. So now I have my two things in my statement column. But what allowed me to write each one of those? I added this plus this to make the whole. What postulate allows us to add together pieces of a segment? That's the segment addition postulate. Okay? Now, my last step is, since all of this is equivalent to this, I can replace this with ML. So now I can say, in place of this, I can say, well, that's the same thing as length of ML. And I can do the same thing here. In place of this, I can replace it with this. Okay? So what lets me take something of an equivalent value and replace it? The substitution property. Okay, so that is our first proof. We are done when this last line of the statement column matches the thing that you are trying to prove. That's when you know that you're done.